Welcome to Preeminent Test Prep. Today is day 5 in our 90-day SAT prep series. We'll be getting into the SAT reading section first, and then we'll do the math section after that. So let's go ahead and get started with a review of what we learned last time in the SAT reading section. So last time we discussed the format of the SAT reading section and what it was comprised of. So we have 52 multiple choice questions. We have 65 minutes to complete all of those questions, which means that we have to average 13 minutes per question set or per passage on average throughout the SAT reading section. We discussed that there were 5 passages in total, 2 history or social studies passages, 2 science passages, and then 1 United States or global literature passage. I discussed the order that we want to approach them in. We want to go from our easiest passage to our hardest passage. So if you're strong in science, you're going to want to do those first, and if you're strong in literature, you'd want to do that first. So we want to go from easiest to hardest. And then we talked about how usually one of the passages will have 2 passages that you have to compare, contrast, and analyze. Then we went over what's tested on the SAT reading section. So that's going to be your command of evidence. That's going to be your ability to interpret words in context and to analyze data. We talked about how we want to make sure that we understand that only one of the answer choices can be correct. So we want to make sure we can get rid of 3 answer choices because they are incorrect, right? So we want to pay attention to context. We want to make sure that we're not just selecting synonyms when we're doing words in context. We want to come up with our own answer choice first so that we're not swayed by the other answer choices, and we want to make sure we're looking for 3 wrong answers. All right, so we talked about data analysis, how you're not going to have to do math, but you will have to apply information from tables and graphs and diagrams to the passage and its content. So this will be covered in practice problems, and we'll also review the math section with tables and graphs. That will also help you. And there's some crossover with the writing section, and that each of them will have tables and graphs that you have to be able to apply to passages. All right, so we talked about successful strategies. So like I said, we want to go from our easiest section to our hardest section. Over time, you'll learn which sections you're better at and which ones you're worse at. We always want to start with the ones that we're better at so we maximize the points that we'll get. So I said that everyone's different, but the strategy that I would recommend is to begin by reading the passage. And when we read the passage, we aren't skipping lines, but we're also not trying to do too in-depth of a read-through on our first read-through. So first read-through, we're not skipping lines, but we're also not taking time to write lots and lots of notes. We want to write little to no notes. We're really, the only notes that I would recommend taking are going to be symbols or underline, so that way you don't have to stop reading. I recommend reading all the way through, and if you want to mark things up as you go, that's okay, but just make sure you're never stopping reading to write, because then you're probably spending too much time on your first read-through, because you don't know what will be important yet, and you only really need to know what the questions are asking. So, well, you also need to know the big picture, but you only need to go back and kind of look at those parts that the question's referring to. So we want to make sure we stay interested in the passage, because if we're interested in it, we're going to remember it better. And then I talked about how you should take less than 5 minutes to read the passage, right? So your first read through should take less than 5 minutes, preferably under 4, and even more preferably about 3.5 to 3 minutes on that passage. Now, if your passage is one with 2 passages that you're going to have to compare and contrast, then it might take more like 4 or 5 minutes. All right, so then we left off at approaching the questions. So that's where we're going to begin today. So your approach is going to change as you recognize question types and patterns, etc. So that should say patterns right there, not patterns, right? Patterns. All right, so approaching the questions. So as you go through this 90 days, right, you're going to end up doing more practice problems and practice passages. And at that point, your approach is going to start to change because you're going to recognize question types, and that's going to help you get to answers very quickly. So your approach will kind of be altered as you go through and you see where you're strong at. But to start, you're going to kind of go through what I detail down below. But eventually, like I said, you're going to develop a feel for the reading section, and you'll have your own strategy, your own way of dealing with questions, and your own way of approaching each passage, because everyone is different, but there are commonalities that can be taught to help you improve your score. So now we get into what I'm recommending at first, right? So at first, I'd recommend going in order, and I'm going to switch to a highlighter here. So going in order until you determine what your easiest to hardest sections are, right? If you have a general idea of that, if you know that you're really strong in science and not super strong in literature, then it's okay to go ahead and start with those science ones and end with the literature ones. But if you're not sure yet, then I would just recommend going in order, right? And then as far as questions go, once again, I'd recommend going in order to start, right? And then skipping questions that you feel really unsure of after 35 seconds. And this is in the beginning, keep in mind. So your first practice test, I'm recommending that you skip a question if you're really unsure of it after 35 seconds, right? So if 35 seconds have gone by and you've read it a second time, for example, right? So if you've read through a question a second time, and you still don't know what it's asking, then you need to skip it, right? Because if you've read through it twice and you still don't understand what the question is looking for, you're probably not going to get any more, you're probably not going to get any better by just looking at the question a third or fourth time. So if you've read through it twice and you still don't understand it, then I'd recommend skipping it and come back to it at the end after you've answered the rest of the questions. All right, so try not to skip more than 3 questions on one passage, right? Because if you spend all that time reading that passage, you want to make sure you're rewarded for your time reading that passage. And if you skip more than 3 questions, there's generally 10 questions per passage. All right, so I'll go ahead and use my pen real quick, switch to that, if it'll let me. All right, so you've got 10 questions basically on each passage, right? So if you're skipping more than 3, then the most that you can be getting is 60%, right? So that's the most that you could get for reading that passage if you're skipping more than 3. And we want to be getting more than 60% of our effort back from reading that passage. So if we're going to take the time to read a passage, we don't want to skip more than 3 questions on that passage, because then we're not getting rewarded for the time that we spent reading that. And the SAT is timed, so we want to be rewarded for that time we spend on it. All right, so my next tip is going to be use the text, right? So a lot of times on the SAT reading section, you'll be directed back to lines in the text, in the passage. So for example, if a question said, in lines 51 to 56, what is the purpose of the author including the quotation from Clarence Thomas, right? And I don't know who Clarence Thomas is, but he's just a made-up person. Then you'd have to go back to that line 51 to 56. You want to read through it, and you might even want to start a little bit before it and end a little bit after it to get some more context if you don't remember exactly what it was talking about. And then you're going to formulate your own answer and then go down and look at the answer choices and find which one matches your answer. So we always want to use the text. Whenever we're directed back to lines, we always want to make sure we go back to those lines. So anytime you see line numbers in a question, make sure you go back and look at those line numbers to get a better idea. Trying to go off of memory can be really dangerous on the SAT reading section. We always want to go back to the text to make sure we're correct, especially if you're aiming for over a 700 in total on the writing and reading section together, or if you're aiming for over a 350 on just the reading section. So like I said, the text is going to be your best friend because all answers have to be supported by it, right? So it's basically like a cheat sheet for your answer choices, right? Or for your questions to answer them. They're basically giving you the answers. The answers are in the text. You just have to go find them, right? So you want to make sure you're using that text because that is your answer sheet, right? Every single question that is asked must be supported by that text. So that text is your answer sheet. That's where all the answers lie. So make sure you're using it. So if lines are involved, like I said, make sure you're going back to them, right? If it says in lines 50 to 60, go back to lines maybe 46 to 64 so you get some context in there. If it says in line 51, what does this word most nearly mean? I would start in maybe 47 or 48 so you can get some context before you say what that word most nearly means. And I would also end a little bit after it, so you're making sure you're getting that context in. Because the reading section does ask what words in context mean, so you don't want to miss the context by only reading that singular line. All right, so like I said, you should find yourself going back to the text in a lot of questions, right? Use that text, use that answer sheet. All right, so now we've got eliminating wrong answer choices. So this is huge for the SAT reading section. This is what can help a lot of people who are struggling get a lot better, a lot faster, right? Once you start to understand that you have to accept that the fact that there's only one correct choice, you can't be debating between two because only one can be correct. And after you take a practice test, you have to acknowledge the questions you got wrong and don't try to debate with the College Board, okay? So you have to eliminate wrong answer choices. If you can get rid of 3 answer choices, then that means you found the correct answer. Even if you don't know if it's correct, as long as you know the other 3 are wrong, you know it has to be correct. All right, so this means we have to be ruthless, right? We have to be absolutely ruthless in how we're eliminating these answer choices because otherwise we're going to get stuck between 2 or 3 answer choices. So if any part of the answer choice is wrong, then all of it is wrong. So if any singular word, right, any one false word is going to make the whole answer choice wrong. So any single word in an answer choice that is not supported by the passage or that cannot be inferred from evidence in the passage makes that answer choice wrong. So you have to get rid of it. So there are common wrong answer choice types on the SAT reading section. If you can identify these wrong answer choice types, it can help you eliminate answer choices. All right, so this 1 through 6, they aren't necessarily in order of probability or how much they show up on the SAT, but I'll try to give you a bit of an idea of my opinion on how often they show up. So we got 1 through 6 here, right? So these are basically 6 types of wrong answer choice types on the SAT reading section. So the number 1 type is going to be broad, and this shows up a lot, so does narrow, right? So if your answer choice is too broad, right, it's too broad, too general, it's not specific enough to the passage. So this would mean that it does not extend beyond the big picture. So this would mean if your answer choice is, it should say extending beyond the big picture, not do not extend, right? It's extending beyond the big picture, right? So you read your passage, you come up with your big picture. So you've got your big picture, right? Let's say that the big picture of the passage, the main purpose of the passage, and I'll get into big picture in a minute, but let's say that the main purpose of the passage is that the growth of worms in the Amazon forest is increasing at a rate of 10% per year, and this is going to cause ecological problems. Well, if we're going to be too broad, we would say that the insects in the rainforest are growing fast, right? That's not specific enough because we were specifically talking about the earthworms, right? So that would be an example of a too broad answer choice. If we were to say insects instead of those earthworms, if that whole passage was about earthworms, not just a single part, but that whole passage was about how earthworms, their population is growing a lot and how that's going to cause ecological problems, it would be too broad if we said that the insect population is growing in the Amazon. So that would be an example of a question type where the answer choice is too broad, right? So that's going to be a wrong answer choice. Next, we would have too narrow. So let's use that same example. So let's say our whole passage was about earthworms are rapidly populating in the Amazon forest, and that's going to cause ecological problems. Well, what would be too narrow then is if we were to only focus in on the earthworm population increasing, right? And we ignored the ecological problems that that is going to cause, right? So if it was to say a question about the main purpose of that, right? So the main, for example, the question could say the main purpose of this passage is what? And then if we were to say the main purpose is talking about the increase in earthworm population, we would be wrong because we're not including that whole part, right? We're focusing too much on just the earthworm population. The correct answer would be that the main purpose of the passage is to discuss how the increase in earthworm population is causing ecological problems in the Amazon rainforest, right? So we want to make sure we're not focusing in too much on a single part of our passage, right? We want to keep that big picture, that whole purpose. All right, number 3, not related or off topic. And there will be answer choices on the SAT reading section that just don't really have anything to do with your passage. It's kind of rare and it doesn't show up a ton, but there are definitely times where there's just an answer choice that you can immediately say is wrong because it isn't related and it's completely off topic to the passage. All right, so the next incorrect answer choice type is going to be an incorrect relationship. So this can also be called a reversed relationship. So let's say that we were talking about how, let's say on a specific small part, so let's say this is about one paragraph of that same reading section I was talking about with earthworms in the Amazon rainforest and how their increased population is causing ecological problems. A reversed relationship would be that, let's say we said that the earthworms, here, I can't write right now because my hand is injured. So let's say, I'll just go ahead and speak it. So you're just going to have to write this in your notes. All right, so the incorrect relationship would be, let's say that the increased earthworm population is causing a increase in the population of Venus flytraps, and these Venus flytraps are diverting water from rivers due to their increased growth from being able to feed on these earthworms, even though they probably don't feed on earthworms, right? So basically the correct relationship then is that the increased earthworm population is causing Venus flytraps to divert water from rivers, and these rivers are drying up. So a reversed relationship would be if we were to say that the increased Venus flytrap population is causing an increased earthworm population, right? So that would be reversing that relationship. So we want to watch out for incorrect relationships and reversed relationships. I'm going to put that right here, / reversed relationship. All right. So beware of incorrect relationships and reversed relationships. Always make sure that your relationship and your correlations and causations are accurate. All right, so the next type of incorrect answer choice you'll see on the SAT reading section is an unsupported answer choice. Right, so this is kind of vague and kind of general. I'll acknowledge that. But it's any answer choice that can't be supported by the text. Any answer choice that can't be supported by the text needs to be eliminated. So a lot of times what will happen is you'll have an answer choice, and it sounds like it could certainly be correct, right? You are saying You're hearing things in the text that make it sound like it's certainly plausible that this could be correct. The problem is something being plausible that it's correct doesn't make it correct, right? It has to be supported with evidence. So there's a lot of questions where the answer choice is possible, it could be correct, but because it's only plausible and it can't be supported by the text to say for certain, that can't be correct, right? So that is the other type of incorrect answer choice. And then last one, number 6, is doesn't follow the big picture. So before I get into that one, I'll go ahead and explain what the big picture is, right? So this is an idea on the SAT reading section that we need to zoom out and focus on the theme of the passage, right? The overall purpose, the overall message, what is the author trying to communicate with this passage, right? So that's the big picture. So if we were to read that passage about the increased population of earthworms causing ecological destruction in the Amazon, the main theme, if we were to zoom out, the big picture would be that full theme, right? So the big picture, in my mind, would be the following. So I'm going to begin right here. This is the big picture. The increased earthworm population is causing an increased Venus flytrap population, which is diverting water from the rivers, causing ecological destruction, right? And that even is probably a little bit too zoomed in, right? So if we're going to zoom out even more to get even bigger of a broader picture, it would just simply be the increased earthworm population is causing ecological destruction in the Amazon rainforest. That would pretty much be a perfect big picture, was that right there. So we don't even necessarily have to include the fact that it caused that increased population of Venus flytraps and that diverted water from the river, because then we're getting into kind of specific details, right? So really the best big picture for that reading section that I just gave you would be the increased earthworms population in the Amazon rainforest is causing ecological destruction in the Amazon rainforest, right? So that would be it right there. That's your big picture. So we want to make sure that we're zooming out. We're not focusing too much on details, right? So if we were not zooming out, let's say that, I'll give you an example of an incorrect big picture, right? So that with that same thing, an incorrect big picture would be if we were to say the increased Venus flytrap population is caused by the increase in their metabolic rate from digesting more earthworms, right? We're missing the big picture because we zoomed in too much on the role of Venus flytraps there. And we didn't zoom out and really examine that whole cause and effect, with the cause being the increased earthworm population and that final effect being the increased ecological destruction in the Amazon rainforest. So we don't want to zoom in too much on that Venus flytrap part of it, for example, right? We don't want to zoom in too much on one paragraph out of a 5-paragraph passage. So we want to make sure we're getting the big picture. We want to tie everything in the passage together. So that's going to be your overall message, your overall feeling, and the overall motive behind the author making this passage. So don't be the guy looking at the clock in the corner of your screen and miss the lesson, right? So this is kind of a reminder to stay focused on the lesson. Don't be looking at the clock because it's an hour long. Don't be counting your time. But also, let's think about it like this, right? If I'm teaching you a lesson, like I am now, and you're looking at the clock in the corner of your screen, what are you doing? You're zooming in. You're not looking at the big picture and you're not looking at the theme. That's the same with the SAT reading section. If you're looking too much at one paragraph and not enough at the whole essay or that whole passage as a whole and connecting things together, then you're going to get questions wrong. We want to examine the big picture and not focus too much in on one paragraph. All right, so next up, we've got question types. So now I'm going to get into some question types. So basically, I'll be describing the question types, right? And then I also have included here the percent that the test is made up of these different question types based on 8 SAT practice tests. And keep in mind, I did not myself calculate these percentages. I actually got them from Prep Scholar. They did a breakdown of every question type in SAT reading by percentage. So this last name, Lindsay, she went through and I believe it's Samantha Lindsay, she went through and she calculated the percentages. So this is my sourcing her work right here. You can find her link right here. This is her percentages from this article right here. So that's my sourcing right there. All right, so let's get into it. So big picture questions. So these big picture questions, I'm going to give you an explanation for it. So you should take notes on each one of these question types, right? So this is going to be about the next 11 minutes is me discussing these question types, what to look for on them, and what they consist of. So I might not write everything down for each question type, but make sure that you do in your notes. All right, so we've got the big picture. So this is the question type that talks about the overall message and the overall theme of the passage. So a big picture question type, we want to make sure that we zoom out and we do look at that big picture. We want to make sure we're looking at the overall message behind the passage. If we were to sum it up in 1 or 2 sentences, what would we say? That's going to be our big picture, right? So questions on that, they will include something like, what was the purpose of, say the author's name was Wilder. What was the purpose of Wilder writing this passage to the doctors in Nigeria, right? Let's say that was a passage about vaccinations and how they can be used to prevent disease in Nigeria. So that could be an example, right? We want to look at the big picture then. So we'd be looking at what overall did that passage say, or that letter to those doctors in Nigeria say. So next question is evidence support. So evidence support questions, they should be your best friend, and here's why. Because A, they're 20% of your reading section score, and B, they are very easy once you get the hang of them, right? All that it is, it's supporting your answers with evidence. So for example, you have a question before it, and this could be an inference question, this could be a little detail question, this could be or it probably won't be a little detail question. It's more than likely going to be an inference question, a function question. Those are really the two that I would see being the most likely to proceed an evidence support question, right? So an evidence support question means that you're going to have a question before it. That question could be, what is the purpose of the author writing about his childhood growing up in Nigeria, right? So the author is talking about his childhood growing up in Nigeria, and the question is, what is the purpose of that, right? So then you'd have to go through and you have to find evidence then that supports whatever answer you picked to that. So you have a preceding question where you have to pick your answer choice A through D. The next question will say, which of the following pieces of evidence supports your answer the best? And it'll give you some lines. You have to go back and support it. The nice thing about these is since you should be supporting your answers with evidence anyways, they should be free points. All right, so the next type of question is going to be words in context. So these are going to be your most nearly means questions. So what I recommend for these is these are going to be a question type where you're going to have a passage, right? You got your passage. The question will say, as used in the context of the passage, the word broken most nearly means what in line 53. So then you go back to line 53, but we don't go back to line 53 because we go back to line 49, right? We want to go back about 4 lines to get some context. So then we're going to read from line 49 then to line about 55. And this is for a question on line 53, right? So that way we get some context on it. So we read through, we come up with our own answer first before looking at the answer choices. So we come up with our own answer of what that word means in context. Then we go down, look at our answer choices, select the one that matches our answer. And if none of them match our answer, then we go through, go back to the text, go back to line 53, look at the answer choices and see which one most nearly matches our answer. Now that doesn't mean that it's going to be the answer choice that is a synonym of the word, but it does mean that it'll be an answer choice that matches what that word means in context. All right, so next up we have the little detail questions. So little detail questions are questions that will refer you back to something between 1 line and 10 lines or 13 lines, right? So 1 paragraph, pretty much anything up to 1 paragraph. And it'll ask you about what basically the purpose is behind including that detail. So for example, if an author, we'll go back to our example of a letter to doctors in Nigeria about vaccinations, right? A little detail would be that vaccinations have decreased the rate of death of people with polio by 90%. And I don't know if that's true, so don't fact check me. That is not accurate at all, probably. But let's say that that's our detail, right? Then we're going to be asked about the purpose. So what was the purpose of including that detail, that 90% decrease in the rate of people getting polio and dying from it? Well, the purpose of that is to show how important vaccines are because they prevent disease, right? So our answer for why we included that would be something like to show the decreased death rate of people who receive vaccines, right? To show how good vaccines are, to advocate for vaccines in Nigeria. All right, so then the next type of question we've got is the inference question. So the inference question is going to be something where you have to either compare, right? So that would be comparing what an author said to another. The inference section will often show up with 2 passages, right? So a lot of times it'll be, you read 2 passages, you're asked to infer what the author of one would think about what the other author's perspective is, right? So let's say that we had 2 passages. Each of them were about whether or not the United States should admit Texas as a slave state or a free state, right? So back in the 1800s, Texas became a state, and they had to decide whether it would be a free state or a slave state. So you would likely have two passages, one advocating for it to be a slave state and one advocating for it to be a free state. So an inference question would be something that would ask something like, what would the author of passage 2 think about what the author of passage 1 said in lines 25 to 30? And then you'd have to go through and infer based on what you read in passage 2 and what that author's argument was, what he would think about what the other author said. So that would be your inference question. And once again, make sure you're using the text on that. Next up, you have function questions. So function questions would be something like this. It'd be something such as what is the function of including the statistic in line 15 to 18 on the passage as a whole? Or what was the function of including a quote from Dr. Janelle, and then whatever her last name is, in lines 20 to 25. So it's all about the function of things that the author did. Next, you have your data reasoning questions. So these are going to be your things dealing with tables and graphs. So you're going to be given a table or a graph, and you have to apply it then to the reading passage and in the context of the reading passage. So you got to make sure that you read the passage for that. You can't just look at the graph because you're going to have to apply it to the context, right? If it was just about interpreting a graph, then it wouldn't be on the reading section. You have to understand the context which surrounds it, which means you have to read the passage as well. So you're going to read through the passage. You're going to get to your data reasoning questions, which are usually the last questions in the passage. You're going to look at the graph or the table. You're going to interpret whatever it says and then apply that to the passage. All right, so then the last two are going to be the analogy and the author technique questions. These are pretty rare. As you can see, 2% each, so they're not going to be a whole lot of time devoted to those in this 90-day series. The analogy question is usually going to be, you're going to have some relationship in your text, and you're going to have to compare it to a relationship outside the text, right? So let's say that the relationship was that the increased earthworm population is causing an increase in the Venus flytrap population for some reason. Then you'd be given two other sorts of either animals or objects or whatever, or relationships, and you have to compare whether that relationship is similar to and you have to compare whether that relationship is similar to that of the earthworms and the Venus flytrap. So that's the analogy question. Then the author technique question is going to be talking about the tone and the mood of the author. So that's going to be a lot of questions about what kind of mood does the author develop in paragraph 1, what kind of tone does the author set in paragraph 1, questions like that. So that is really just making sure that you understand the big picture as well. If you understand the big picture, you should be able to get the author technique questions down pretty easily. All right, so that's going to be all for the reading section today. So tomorrow we will have the writing section and the math section, and we'll go ahead and switch to the math section now. All right, so let's get into the math section for day 5 of our 90-day SAT prep series. So today we've pretty much covered all of the equations, but about 3 of them that I want to show you. So I'm going to go ahead and take today, we're going to review the about 30 or 32 or 33 or 34, 35, however many equations we got so far. And then we're going to review all those, make sure you have those in the first 20 minutes, make sure that you're comfortable with those. And then after that, in like the last 10 minutes, I'm going to teach you about 3 to 4 new ones. So those 3 to 4 new ones will pretty much be the last ones we cover. And then after today, we'll start getting into some practice problems. So we're going to start with the easier practice problems in the first week, and then we're going to develop into some harder practice problems. So we'll go ahead and get started with our review of our equations that we've learned so far. So we've got y equals mx plus b. That's our slope-intercept equation. We have b as our y-intercept because when x is 0, we see that y is equal to b, which means that that is where our y-intercept is at. So we got our slope is going to be m. So if our slope is 2, then we would have 2x. All right, and then we've got our vertex form of a quadratic as our next equation. So if our vertex is hk, then our equation is going to be y is equal to a times the quantity x minus h squared plus k. And then we've got our quadratic formula right here, right? Not our quadratic equation, that's later on, but if we're going to write this in the equation of a parabola that isn't in vertex form, then that would look like this. That'd be y equals ax squared plus bx plus c. If you were to go ahead and do x minus h squared, then that's what you'd end up with over here. All right, so that's your vertex equation. We know that if a is positive, then we're going to have an upward sloping, or a U-shaped, all right, positive U-shaped, if a is positive. If a is negative, then we have k as a maximum. If a is positive, we have k as a minimum, right? So if a is negative, we're going to have downward facing graph. All right, our distance formula. We've got our distance is equal to our square root of our run squared plus our rise squared. That could also be written as in long form. Our distance is equal to the square root of our second x point minus our first x point squared plus the difference between our two y points squared. So that's our distance formula. Next, we've got our quadratic formula. All right, so our quadratic formula is y is equal to ax squared plus bx plus c, right? That's not our quadratic formula. I'm sorry, I misspoke right there, right? That's not our quadratic formula. That's like the formula of a parabola, right? So our formula for a parabola is y is equal to ax squared plus bx plus c. If we're going to find the roots, we use the quadratic formula, right? So to find the roots of an equation that looks like this, right? So if we're given an equation that looks like this, we have to find the roots of it. Then we're going to use this equation right here. This is our quadratic formula. Keep in mind that there's different words for that quadratic formula and what it equals, right? So that quadratic formula, it's going to give you the roots, which are also called the zeros. All right, so either of those, if you see what is the root and you're given an equation like this, then you're going to want to either factor it to find it or use the quadratic formula. If you're asked what a zero is, then you're going to want to make sure that you go ahead and use either the quadratic formula or factoring. We'll do more factoring when we get into practice problems because it's a lot easier to see through that way. So those can be called your roots or your zeros. So that equation is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And we're going to get into a little trick with that b squared minus 4ac at the end. That's another equation I want to show you, or another rule or trick we can use. So we're going to get into that later on, so just keep that in mind. All right, so then we talked about exponents, right? So exponents, we've got, if we have the same base, then there's tricks we can use. So if we've got the same base, let's say that our base is z, we have z to the power of x times z to the power of y, then that's going to give us z to the power of x plus y, right? So that q then would equal x plus y. So like we said, if we have x is 15 and y is equal to 9, then we would have z to the power of 15 plus 9, which is z to the power of 24. Next, we did dividing. So if we have the same base and we have z to the x over z to the y, we can go ahead and subtract them. So that would equal z to the x minus y, which means that q then would equal x minus y. Next, we had a power to a power. So if we have z to the power of x raised to the power of y, then that means that z is going to equal, or that will equal z to the power of x times y. All right, next we had the difference of perfect squares. So the difference of perfect squares is when we have our x minus y times our x plus y, and that's going to give us our x squared minus y squared because our middle terms are going to cancel. So anytime you see that you have an x minus y times an x plus y, understand your middle term will cancel and you only have to worry about your x term and your y term, not the xy term, because they'll cancel out. All right, next equation that we have is our positive trinomial equation. All right, so if we have x plus y squared, then that's going to equal x squared plus 2xy plus y squared. This is the one that you should memorize because it'll save you time. If you don't memorize it, like I showed you right here, then you're going to have to factor everything out and it's going to take you a little bit more time. But if you can just recognize x plus y squared is going to equal x squared plus 2x times y plus y squared, that'll save you some time, so I'd recommend that. Next equation we did is just the negative version of that. So this is the negative trinomial perfect squares rule. So that's going to be if we have x minus y squared. If we have x minus y squared, then we're going to have x squared minus 2 times x times y plus y squared. So if we have a minus sign right here, then we know that we are going to have a minus right here. And if it's a plus sign, then we'll have plus 2xy. All right, so next we got into day 3. We did some review. All right, we went over what I just reviewed, all of our exponents. We did positive trinomials. Then we got into our complex conjugates. So if we're given an imaginary number and we have to get rid of our imaginary number, then we're going to multiply by its conjugate, right? So let's say that we had a plus xi, then we're going to multiply by a minus xi to give us a squared plus x squared, and now we no longer have an imaginary number. So if you're given an imaginary number and none of your answer choices have an imaginary number, or you're asked to remove your imaginary number, you're going to multiply by the complex conjugate. So if you have a plus xi, you multiply by a minus xi. We know that I squared is equal to negative 1. That's an important thing to know for the SAT math section. It could also be important to know I through I to the fourth, right? So I to the fourth is 1, I to the third is just I, and I is equal to the root negative 1. So I squared equals negative 1 is the most important of those four. So if you can only remember one, make sure you remember that I squared is equal to negative 1. All right, next we got into some science and financial models. So first one's a science model, and that's going to be y is equal to a times 1 plus or minus r raised to the x. So in this equation, we remember that a is our initial or starting value, and this is an exponential growth or decay equation. We have r as our rate of growth if it's positive. So if we have a positive rate of growth, it's going to be 1 plus r. If we have a rate of decay or a negative rate of growth, then we're going to have 1 minus r. So remember that x is going to be time as well. All right, so then our next equations were pretty much solely financial models. So we have simple versus compound interest. We remember that simple interest means that we do not have to pay interest on our interest, whereas compound interest means that we have to pay interest on top of the interest that we already owe. So simple interest is A is equal to PRT, where A is the amount and T is time, and R is the rate of interest per unit time. P is our principal amount or our starting amount. So one thing to keep in mind here is that if we were asked how much interest is owed on a $1,000 loan at an interest rate 5% after 3 years without compounding, it's actually going to be less than that 1,000 because we're asked about interest, right? If we're asked about interest, then R does not include our 1. But if we are asked about the total amount owed, then that would be 1,150 because then we have to include that $1,000 loan. So if we're going to be asked about the total amount owed, we have to do 1.05, but if we're only asked about the interest owed, we remove that 1 and we just do multiplied by 0.05. So next we have compounding interest. So compounding interest, that's going to be our amount is going to equal, once again, our principal amount or our starting amount, the amount of our loan, times the quantity 1 plus r, where r is our interest rate, divided by n being the number of times compounded per 1 unit t. So for an example here, if we're going to compound it quarterly, which means 4 times a year, then n is going to equal 4, and that means that t will equal 1, right? So our number of times compounded per 1 t, right? So 4 times per year is quarterly, so that would mean n is 4 and t is 1. If we're going to use monthly, then n would be 12 and t would be 1. So that's our equation right there. So we've got A is equal to P times quantity 1 plus R over N raised to the power of N times T. So once again, same thing, make sure that you understand whether you're doing for interest or for total amount owed. Next, we got into some statistical analysis on the SAT math section. So this included the equation for the average as well as 2 concepts that aren't equations, or 3 concepts that aren't equations. So we'll start with our equation for average. That's going to be our sum over our count, right? So our example that we had was this graph right here. We had our number of people and our age. So we see that we have 3 people who are 10 years old. So we did 3 times 10. We have 1 person who is 20. So we did that 30 plus that 20, and then plus our person who is 5 years old. So that gave us 55. We see we have 5 people. So we did 55 over 5 to get 11 as our average age. So that's how you find the average or mean. Keep in mind that the mean is the same as the average. All right, so next we got into statistical concepts that were not equations. All right, so these statistical concepts included random sampling. So random sampling, that is when our goal is to create an unbiased and reliable sample, which means that it has to be random. If we do not have a random sample, then it could have bias and not be reliable. So that's something you definitely need to know for the SAT math section because they do test statistics and interpreting random samples on that for certain. It's not on every test. It doesn't have to be on every test, but it's on a lot of them, in my opinion. So the average children per household in a city, if we were asked to collect data on that, we would not want to do it at a playground because that's biased because people at playgrounds tend to have more children, right? You wouldn't be really attending a playground if you don't have a child. That would be very, very weird. Do not do that. So the goal is to have an unbiased and reliable sample. And then we've got random assignment as our next part. So random assignment, that occurs once we have our random sample. So our random sample is unbiased, right? At that point, it's been random, which means it's not biased. At that point, we randomly assign people to different groups because that way we keep that sample unbiased. If we were to take a random sample and then split them into groups based on hair color, then we're not doing random assignment. Random assignment means each person is getting a random number and they're randomly divided up based on those random numbers. So everything is random. They're not being split up by hair color or by any differentiating trait. All right, so next we have standard deviation. So standard deviation, you do not need to know the formula, which is probably a good thing because the formula is slightly complex. It's not too bad, but it's good that we don't need to know it because anything that we don't need to know for the SAT is probably a good thing since we want to score highly on it. All right, so the formula for the standard deviation is unnecessary to know. We've got our 2 types of plots right here. So we've got scatter plots, right? Now, if we're going to go ahead and decide which one has greater standard deviation, that would be plot number 2 because Standard deviation is a measure of how much we deviate from our average. We see our average for each plot is at 20, right? Our average for each plot's at 20. So the question is, which one deviates more from the average? Well, if we look at plot 1, its deviation from its average is only about 7 years, right? But if we look at plot 2, its deviation from its average is 15 years. So that means that there's a greater standard of deviation for plot 2. So plot 2 has a greater standard of deviation than plot 1. That would be what we would answer for a question on standard deviation. All right, so then we got into some geometry and some trigonometry. So to start, we talked about the equation for the area of an equilateral triangle. We said that the equation for the area of an equilateral triangle is the square root of 3 times a side length squared, because all sides are the same. So keep in mind, if you see 60-degree angles in each corner of a triangle, it's equilateral. If you see this right here, right, it's pointing down, where you have a 1 line on each side, that means it's equilateral. If all 3 angles are the same, like right here, that means it's equilateral, right? Now, you don't necessarily have to memorize this one because it can be derived, but I would highly recommend memorizing this equation because it'll save you time, and the SAT is timed. So our area is going to equal the square root of 3 times s squared divided by 4. That's for an equilateral triangle, though. If we're talking about a triangle that isn't equilateral, or that doesn't have all 3 sides equal to each other, the area of that triangle is going to be a equals 1/2 b times h being this height right here, and b being your base, so base right there. Base right there. All right, our next equation. Next equation that we had is our circle equation. So we had our radius squared is going to equal x minus h squared plus y minus k squared. So once again here, just like our vertex formula, hk is our center. So keep in mind that if h is positive, then we're going to have x minus, and then if h is negative, then we're going to have x plus. Same thing with k. If k is positive, we're going to have y minus. If k is negative, we're going to have y plus. All right, so next we've got our trigonometry. So we covered the sine, the cosine, and the tangent in our trigonometry. I taught you SOHCAHTOA, so I would go ahead and make sure that you memorize this right here. This sine is the opposite over the hypotenuse from your angle. Your cosine is your adjacent side from your angle divided by the hypotenuse, and your tangent is your opposite side from your angle over hypotenuse. So go ahead and take a look at those. I'll give you about 10-15 seconds to take a look at those equations. Make sure you have them down in your notes and that you're comfortable with them. If not, then I'm going to zoom out so you can look at what they equal in our reference triangle right there. So go ahead and take about 10 more seconds. Make sure you have that understood. All right, now we can go ahead and move on. So now we've got the Pythagorean theorem. So the Pythagorean theorem, that's going to be your a squared plus b squared equals your c squared. So we could have a as 8 and b as 6, then that means c is going to be 10. How do we determine that? Well, we plugged in a squared. We know that a is 8, so we had 8 squared plus b squared. B was 6, so that's 6 squared equals c squared. So we got 64 plus 36, that gave us 100, and then we went ahead and took the square root of each side. Square root of 100 is 10, so we have c equals 10. All right, next thing we covered is degrees and radians. So if we're given degrees and we want to convert to radians, we know that we have to multiply by pi over 180 because pi radians equals 180 degrees. Likewise, if we were given radians and we wanted to convert to degrees, then we have to do our radians times 180 degrees over pi radians. So make sure you understand both of those. Once again, I'm going to give you about 15 seconds to make sure you understand those before we move on. All right, so now let's go ahead and move on to polygons. All right, so like I said, a polygon is a side or a shape with many sides. Prefix poly means many, so we've got a many-sided shape. We know that our interior angle of a polygon, that's really pretty much I think that's everything you need to know about a polygon. I've never seen anything else. So the interior angle of a polygon, if we have to determine that, we're going to use this equation here, this n minus 2 times 180 divided by n. So this is going to work for any polygon, right? It can be used on a square, it can be used on an octagon, a hexagon, whatever kind of gon you want. So you've got n minus 2 times 180 over n. That's going to give you your interior angle of a polygon in degrees. Keep in mind that that's in degrees, that is not in radians, that's in degrees. All right, next up you've got your arc length of a circle. So we covered the arc length of a circle with radians and also with degrees. So if we're given it in radians, then we can go ahead and do our arc length is going to be our angle in radians times our radius. If we're given it in degrees, we can do our arc length is equal to our number of degrees over 360 times our diameter times pi, or times 2 times our radius times pi, because 2 times our radius gives us our diameter. Next, we covered the area of a sector of a circle. So if we want to find the area of a sector of a circle and we have the degrees, then we would do our number of degrees divided by 360 times pi r squared. Since pi r squared is the area of a circle and we are multiplying by the fraction of that angle, that's going to give us our area for that sector. Now if we're using radians, say that we were given radians instead of degrees, then we would do 1/2 times our radius squared times our angle in radians. So that would also give us our sector area. All right, then we covered triangles that you should know. So we had the 3, 4, 5 triangle. So if we have a right triangle and we have 3 on one side, 4 on the other side, then 5 will be our hypotenuse. So make sure that you understand that you have to have a 3 on one side, 4 on the other side, 5 will be your hypotenuse if it's a right triangle. We also have a 5, 12, 13 triangle. So if we have 5 on one side, 12 on the other side, we're going to have 13 as our hypotenuse. If we have 13 as our hypotenuse and 12 on one side, we know 5 will be our other side. Keep in mind also that shapes don't have to be drawn to scale in the SAT math section. All right, so now I can go ahead and get into our equations and tricks that I'll be teaching you today. So one thing that I want to put in is how you can convert from non-slope intercept form to slope intercept form. So we keep in mind that our slope intercept form is y equals mx plus b. So if I wanted to make sure that I can convert to that, let's say that I was given an equation that is, let me pull it up real quick. Let's say I was given an equation 3x plus 6y equals 33. And let's say that I needed to put that into slope-intercept form, right? Y equals mx plus b. Or say I just wanted to because it makes it easier for me to solve a problem. So what I'm going to do is I'm going to subtract 3x from each side. And then I'm going to divide each side by 6. So what that's going to look like is I'm going to have a negative 3x here minus 33. It's an x right there. Right, that's equal to 6y. We're going to divide each side by 6. And that's going to be our slope-intercept equation. So that's going to be y is equal to negative 1/2, because 3 over 6 is 1/2. I'm sorry, my handwriting is really bad right now. All right, 1/2. So we got y equals negative 1/2 x, and then we got minus 33 over 6. And I don't feel like simplifying that. I don't even know if you can, but I'm not going to because I don't feel like it. All right, so next up, I'm going to teach you how to get that slope even faster. Okay, so that's one way that you can do it if you have to find the whole equation for slope, intercept, and converting. Let's say I just needed the slope. So let's say that I'm given 4x plus 8y equals 10. Let's say that I'm just asked for the slope of this equation. Well, if I'm just asked for the slope of this equation, then I know immediately it's going to be negative 4 over 8, which is negative 1/2. So how did I do that? All right, so here's how you're going to do that. Think about it like this. If I was going to take the time to actually go through and do everything, I'm just ignoring this 10 because I only need to know the slope, right? So this is m is our slope. If I'm only asked for the slope, I don't care about this 10 at all, right? So if I'm just asked for the slope, I really don't need to know that there's a 10 there. What I'm going to do is I'm going to go ahead and minus my 4x, right? So I minus my 4x, and then I'm going to go ahead and divide by 8, right? So I see I have minus 4x over 8, which is minus 1 over 2x. Right, so if I need to solve for my slope, all I have to do is take that negative of whatever my x is, so in this case it's 4x, and then divide by the coefficient in front of my y. So in that case it's 8, and then right here I can simplify down to negative 1/2 x. Alright, so the next thing that I want to show you is if you were asked for the perpendicular line to a certain line. So there are two types of lines, right? You've got parallel and perpendicular. So let's go ahead and draw those. So a perpendicular line means that it forms a 90-degree angle, right? So a right angle with another line. Now a parallel line means that two lines are parallel, right? They have the same slope, right? So these have the same slope and they're parallel. So that's same slope and they are parallel. Now, an example of, I'll give a different example. Let's make it a little bit more interesting. Let's go like that, like that. So those right there are perpendicular lines because they form that right angle right there. So those are perpendicular. So you need to know the difference between parallel and perpendicular for the SAT. So I'm putting that in here. Put this in your notes. So now the slope, like I said, for parallel lines is the same, right? So if we had 8x as one slope, then 8x is going to be the other one's slope. Right? Now for perpendicular lines, they do not have the same slope. They have what's called the opposite reciprocal slope. Opposite reciprocal slope. That could also be called the negative reciprocal slope. So either way, whatever you want to put, so the opposite here is referring to the sign, right? That refers to the sign. So opposite sign reciprocal slope. Or you could also think of it as the negative reciprocal slope. So let's say that the slope of our first equation is 1 over 8x, right? And we're asked for the slope of a perpendicular line to that. What we're going to do is, first thing, we're going to flip our sign. So our sign over here is positive. That means we have to flip it to negative for our perpendicular line. The next thing we have to do is we have to flip this 8 up top and flip our 1 down below. That's called taking the reciprocal. Right? So our slope for our perpendicular line would be negative 8x, and the slope of the line that's perpendicular to our negative 8x line is going to be positive 1/8x. So let's do another example. Let's say that we are given a negative 15x line, and we're asked for the line that's perpendicular to that. Well, the line that's perpendicular to that is going to have to flip the sign, first of all. So we're going to have to do positive, and then we're going to have to flip our fraction. So over here was 15 over 1. That means that we're going to have to flip it to 1 over 15. I got to erase that. I just messed up big time right there. That's going to be 1 over 15. Positive 1 over 15. Positive 1 over 15. All right, so there's your slopes and perpendicular lines. All right, so the next thing that we're going to cover is basically a trick, but it's a trick I want you to memorize, which is why I'm including it with the other equations here. All right, so this one has to do with that b squared minus 4ac that I was telling you about. So this one's about determining the number of real solutions. So if you're given a parabola, let's go ahead and say that it is x squared plus 3x plus 22. And I just made those numbers up. I don't really think we're going to use this equation. It's just to show you what I mean. Right? So we have x squared plus 3x plus 22. I'll even put a 3 here just because. So 3x squared plus 3x plus 22 is our equation, right? So that's equal to, we'll set that equal to 0, right? All right, so we have to find out how many zeros there are given this equation. So what we're going to do is we're going to take b squared minus 4ac and determine what that equals. Because if b squared minus 4ac is equal to 0, then that means that there's one real solution. So one real solution. And then if b squared minus 4ac is greater than 0, or that should say equal to 0, then there's one real solution, right? Then one real solution. All right, so if b squared minus 4ac is equal to 0, then there's one real solution. If b squared minus 4ac is greater than 0, or b squared minus 4ac is positive, then there are two real solutions. All right, so then two real solutions. And if b squared minus 4ac is negative, less than 0, then there are 0 real solutions. Right? So you could see a question on the SAT where it asks you how many real solutions there are. It gives you an equation like this. And the quickest way to find the answer is going to be by using b squared minus 4ac, seeing if it equals 0, because if it equals 0, then there's one real solution. All right, then there's one real solution. If it is greater than 0 or it is positive, then there's two real solutions. And if it's negative, then there are 0 real solutions. All right. So another way that this could look is it could look like a graph. Right? So if there is a graph and we had to determine the number of real solutions, then it would look something like this. Let's say that we had a graph that says, or that shows up like this. How many real solutions are there? Well, there are 0 real solutions because real solutions are x-intercepts. Right? We have to cross this x-axis to have a real solution. So this would be no real solutions. And what does that tell us about b squared minus 4ac? Well, that tells us that b squared minus 4ac, since there's no real solutions, it has to be less than 0, so it's negative. Now let's say that we have a graph that looks like this. Well, we see that we have two real solutions because we have one real solution here and one real solution here. Therefore, we know b squared minus 4ac is positive. It's greater than 0. If we have an equation that looks like, I'm going to scroll down, get some more room, that looks like this, right? And it hits right there, just that one spot. So there's only one real solution. It only has 1, 0. And that means that b squared minus 4ac is equal to 0. And there is one real solution. Alright, so that's going to take us through everything that I wanted to teach you for today. We did a lot of reviewing, so that way we can get into practice problems maybe tomorrow. I think probably we'll be able to get into some tomorrow, is what it's looking like, but we will see. So I think that that's everything I wanted to show you, and that'll be it for today. Make sure to like, subscribe, and share. I know my handwriting was pretty bad today. I got like a big cut on my hand right now, so it's tough to write. So that should get better, and my handwriting will improve. So make sure to subscribe, like, and share. Stay tuned for tomorrow. We're going to have day 6 uploaded tomorrow. Today is day 5. If you want to donate and you appreciate what I'm doing, there'll be a donate link in the description when it's up. Make sure to send this out, share it. Thanks for all the support. Make sure you have a great day.